Hi everyone, myself Dr. A. Devi, Professor, Department of Biomedical Engineering, working in Rockney College of Engineering and Technology. In this video lecture, we are going to learn about modeling cardiovascular systems. Initially, we have to know what is a cardiovascular system. It is one of the most important biomedical subsystems of human body and which is responsible of circulation of blood. It consists of heart, blood vessels and blood functioning together to maintain adequate blood pressure. And cardiovascular system is essential to understand the dynamic behavior, and it is used to predict the system responsibles and analyze normal as well as pathological conditions such as hypertension, heart failure and shock. Here by representing the blood pressure flow, blood pressure and blood flow resistance and vessel compliance with equipment electrical components, the cardiovascular system can be analyzed using control system techniques. So in biomedical engineering, cardiovascular system is a model mathematically to analyze blood pressure regulation, cardiac output, effects of diseases, hypertension, heart failure, etc. So here this is the tabular column which compares the cardiovascular quantity and electrical analogy. Blood pressure is same as that of voltage in electrical analogy. Blood flow is current. The analogy of vascular resistance is resistance. Similarly, heart is voltage source. And the cardiovascular system is modeled as a heart that which is used to pump pressure source and peripheral circulation, blood mass, and this overall model is called as Bin-Kessler model. In this model, the system can be divided into two components, R and C. This model equation can be written as Q of t equal to C into dP of t divided by dt plus P of t divided by R. So according to this model, the transfer function can be written as P of s divided by Q of s is equal to R by RCS plus 1. And here the block diagrams representation of the input with the compliance block, resistance block and interns block L. So here this is the block diagram of this cardiovascular system. So one node and heart period and heart rate, stroke volume, circulatory machines and vascular resistance change. So here in this given diagram, closed loop model of this cardiovascular system can be used for measuring the heart rate, stroke volume, cardiac output and blood pressure are regulated. Here and the autonomic control inputs are ANS, that is autonomic nervous system, then sympathetic control, etc. are this control inputs. Then for it is followed by beta. Here is SA node, and this node is which is responsible for our same set of natural pacemaker of the heart, which receives the beta sympathetic, parasympathetic and basal inputs. Along with this basal heart period, these effects are summed to determine the overall heart period. This heart period is given as the period which is then converted into heart rate using the inverse operating system. Here this is SA node block, and here in this block which consists of heart period to heart rate conversion. This heart period to heart rate conversion which is measured as HR equal to 1 by heart period. So here stroke volume SV is calculated as which is depends on venous return, arterial blood pressure and circulatory machines. Cardiac output CO. So cardiac output test can be obtained by multiplying heart rate with SV, that is stroke volume. So cardiac output CO is equal to HR into SV. So here this heart rate is multiplied within stroke volume to produce the cardiac output, which represents the volume of the blood pumped by the heart per minute. So here the vascular resistance, which is used for calculating this higher TPR, that which is increases the blood pressure. And the next one is total peripheral resistance, and which is calculatedly, which is used for leading the variations, and it is circulatory machines block the representations the dynamic behavior of blood vessels, including compliance and intrio, which determines how this cardiac output and the peripheral resistance affect the arterial blood pressure. So next is the uh, circulatory machines block, which block represents vessels, then blood inertia, and this determines the cardiac output, etc. The circulatory machines block represents the dynamic behavior of the blood vessels in the cardiovascular system. And next is the arterial blood pressure, which is controlled. The main controlled variable of the cardiovascular system. And here this next feedback loop, which is responsible for the stroke volume and the circulatory machines. Then arterial blood pressure is sensed and fed back within the cardiovascular system, and the heart acts as the pump, and blood vessels acts as the resistive and capacitive elements. The model is used for study of blood pressure, regulating and analyzing heart diseases, designing biomedical control systems. So overall, this is used for finding the electrical modeling of cardiovascular system, which is related with electrical parameters and sources with the heart vessels and SA node, sympathetic and sympathetic and basal nodes. So cardiac output is the product of heart rate and stroke volume. So this session mainly focused the cardiac blood pressure measurement of mathematical and electrical modeling system. Thank you.